This is the third video of this section, Knowing the Streams. In the previous video, we manipulated and transformed XML documents. This is the new video, I/O in the 21st century, Knowing the Streams. In this video, you'll see the practical utilization of streams, stream writers, and stream readers. Many I/O-related activities handle streams of data. A stream is a sequence of data elements made available over time. As Wikipedia says, a stream can be thought of as a conveyor belt that allows items to be processed one at a time rather than in large batches. At the lowest level, all streams are bytes, but using a high-level interface could obviously help the programmer handle their data. This is the reason why a stream object usually had methods such as read, seek, write, and so on, just to make handling a byte stream a bit simpler. In this video, you'll see some stream utilization examples. In the good old Pascal days, there were a set of functions to handle the I/O, assign file, reset, rewrite, close file, and many more. Now, we've a bunch of classes. All Delphi streams inherit from TStream and can be used as the internal stream of one of the adapter classes. By adapter, I mean an implementation of the adapter or wrapper design pattern from the Gang of Four famous book about design patterns. There are 10 fundamental types of streams, which you can see here. T-binary writer is the writer for binary data. T-stream writer is the writer for characters to stream. T-string writer is the writer for a string. T-text writer is the writer of sequence of characters. It is an abstract class. T-reader reads component data from an associated stream. T-stream reader is the reader for stream of characters. T-string reader is the reader for strings. T-text reader is the reader for sequence of characters. It is an abstract class. T-binary reader is the reader for binary data. You can check out the complete list and their intended use directly on the Embarcadero website at this link. As Joel Spolsky says, you can no longer pretend that plain text is ASCII. So while we write streams, we have to pay attention to which encoding our text has and which encoding our counterpart is waiting for. One of the most frequent necessities is to efficiently read and write a text file using the correct encoding. As quoted by Joel Spolsky, the single most important fact about encodings, it does not make sense to have a string without knowing what encoding it uses. You can no longer stick your head in the sand and pretend that plain text is ASCII. You can check it on this link. The point Joel is making is that the content of a string doesn't know about the type of character encoding it uses. When you think about file handling, ask yourself, could this file become 10 megabytes, and 100 megabytes, and 1 gigabyte? How will my program behave in that case? Handling a file one line at a time and not loading all the file contents in memory is usually a good insurance for these cases. A stream of data is a good way to do this. The project is not complex. All the interesting stuff happens in btn write file and btn read file. To write the file, Team Stream Writer is used. Team Stream Writer, as its counterpart Team Stream Reader, is a wrapper for a T-stream descendant and adds some useful high-level methods to write to the stream. There are a lot of overloaded methods, write line, to allow an easy writing to the underlying stream. However, you can access the underlying stream using the base stream property of the wrapper. Just after having written the file, the memo reloads the file using the same encoding used to write it and shows it. This is only a fast check for this video. You don't need tmemo at all in your real project. The btn read file simply opens the file using a stream and passes the stream to Team Stream Reader that, using the right encoding, will read the file one line at a time. Now, let's run some checks. Run the program, and with the encoding set to ASCII, click on btn write file. The memo will show garbage text, as you can see here. This is because we are using the wrong encoding for the data we are writing in the file. This is the garbage text written to the file using the wrong encoding. No one-line text is equal to the original one. It is necessary to know the encoding for the text before writing and reading it. Now select UTF-8 from the radio group and retry. By clicking on BTN Write File, you will see the correct text in the memo. Try to change the current encoding using ASCII and click on BTN Read File. You will still get garbage text. Why? Because the file has been read with the wrong encoding. You have to know the encoding before to safely read the file's contents. To read the text that we wrote, we have to use the same encoding. Play with other encodings to see the different behavior. Streams are very powerful, and their uniform interface helps us write portable and generic code. With the help of streams and polymorphism, we can write code that uses tstream to do some work without knowing which kind of stream it is. Also, a less known possibility, if you ever will write a program that needs to access the good old std_input, std_output, or std_error, is that you can use thandle stream to wrap these system handles to a nice tstream interface with this code. Moreover, when you work with phi-related streams, the tfile class contained in system io_utils.pass is very useful and has some helper methods to write shorter and more readable code. Moreover, when you work with phi-related streams, the tfile class contained in system.ioutils.pas is very useful and has some helper methods to write shorter and more readable code. Awesome! We now know the utilization of streams, stream writers, and stream readers. In our next video, we will create a Windows service.